Hello and welcome to this podcast. Here in this podcast, we are going to see about Kubernetes security best practices in detail. Kubernetes is an open-source container orchestration tool that has complex architecture and takes a lot of effort to configure and manage. When it comes to deploying the applications in a production environment, two major parts to consider are high availability and security. You need to address the possible vulnerabilities in the Kubernetes architecture and implement security best practices to run the application workloads safely. While working on the Kubernetes clusters, there are many factors we need to keep in mind in terms of security. In this podcast, we will see some of the security practices that can be used to deploy and manage applications using Kubernetes. Possible Kubernetes vulnerabilities. Before seeing the security best practices, let us see some of the possible vulnerability gateways for the Kubernetes so that we can understand why it is so important to follow the security standards. Container vulnerability. If there are any vulnerabilities in the pod configuration, an attacker can get into the container and it will lead to further possible vulnerabilities in networks and processes. Container-to-container connection. If an attacker finds a way to connect to a container, then she can try to connect to other containers and spread malicious files. Vulnerable host. Since most of the nodes are running on the cloud, an attack on any node is a big threat to the cluster it belongs to. Cloud platform vulnerability. Cloud platforms such as AWS, Azure, Google Cloud, etc. expose data to their services that can be accessible by pods. These data may have some confidential information that becomes a vulnerability for the Kubernetes cluster. Unauthenticated access. If Kubernetes APIs are not authenticated properly, attackers can deploy malicious codes. Let's talk about security best practices of Kubernetes. Whether it's on-premise or cloud, most of the attacks rely on network vulnerabilities. Same applies to the containers as well. So securing the network should be your first priority when you think about securing your architecture and deployments. 1. Kubernetes Role-Based Access Control. Role-based access control defines who is accessing the Kubernetes API and what are the permissions the accessor has. RBAC is usually enabled by default, and while using it, namespace-specific permissions are recommended. Always use least privileged permissions and allow access only if it's absolutely necessary. 2. Protecting etcd cluster. etcd is an open-source consistent key-value store for shared configuration. Since it stores critical and sensitive information, it's mandatory to protect it. If the data in etcd is compromised, then it's possible for the person who gets access to take over the cluster. Protecting etcd with TLS is recommended. 3. etcd encryption at rest. We can enable the etcd encryption using the kubeapp observer process. For that, we need to pass the argument encryption provider config. 4. Isolating Kubernetes nodes. As another best practice to make the architecture secure, it is recommended that not to expose the Kubernetes nodes to the public networks. We can utilize Network Access Control List for that. Configure the nodes with Ingress Controller and allow traffic only from the master node on a specific port. 5. Audit logging. Logging or storing authentication logs will help identify any suspicious activity or attacks. Usually failed API calls will show a message as forbidden. There are 4 logging levels available. None, metadata only. 6. Process whitelisting. We need to identify the running processes during the normal application behavior. Process whitelisting will help us to identify any unexpected running processes at a given time. 7. Keeping the latest Kubernetes version. Upgrading Kubernetes is one of the complex processes. Running the latest version of Kubernetes has an advantage of eliminating known vulnerabilities of the previous versions. Check for the automatic upgrade options from the providers. 8. Lockdown kubelet. As we know that kubelet is running on each node, it is used to communicate with container runtime and reports the metrics. Each kubelet in the Kubernetes cluster exposes an API. If an unauthorized user gets access to it, they can take over the entire cluster. So locking the kubelet minimizes the risk for the attacks. Some of the configurations that will help to achieve this are: disable anonymous access, set authorization mode, include node restriction in the API server, turn off deprecated services like cAdvisor. 9. Keep the latest version of Kubernetes. Even though the Kubernetes is an open source tool and maintained by the community, Kubernetes is getting updated very frequently. Keeping the most recent version of Kubernetes minimizes the vulnerability risk. Updating Kubernetes is a complex process, and we also need to maintain availability and have to upgrade with minimum downtime. 10. Using namespaces. Namespaces will be useful in creating boundaries. You need to make sure to use namespaces along with RBAC to restrict access to the resources that are running in the same cluster. Key points. Use namespaces to create isolated environments within your Kubernetes cluster and limit access to resources. Implement network policies within namespaces to further restrict communication between pods and resources. Monitor and audit activity within namespaces to detect and respond to any potential security threats. Use resource quotas and limits to enforce resource constraints and prevent resource overuse or abuse within namespaces. Regularly review and clean up unused or unnecessary namespaces to reduce the attack surface of your cluster. 11. CIS benchmarking. The Center of Internet Security in Kubernetes community has created a benchmark for the security best practices to be followed for the Kubernetes deployment. So, following CIS benchmark checklists is another security best practice to follow. Kubernetes security checklists. The following checklists will help you to protect your Kubernetes clusters and applications. Authentication, authorization, secrets management, audit logging, securing OS, network security, workload security. Though we implement all the best practices, regular scanning of the infrastructure and applications is needed to reduce the attack risk. Containers may have outdated packages with some disclosed vulnerabilities, so it's always better to scan and update the packages. Implementing continuous security vulnerability scanning will help to achieve this. There are open source projects available to identify vulnerabilities. Use Kubernetes rolling update feature to update the application. This will upgrade the latest image. Hope this Kubernetes Security Best Practices podcast will help you to secure your Kubernetes cluster. Comment your views about this podcast and stay tuned for the next podcast.